Hi guys, welcome back to Piping, Welding and DT channel. So again, this is specification, support, details. So in my other videos, they have guide and pipe shoe. Okay, so this is a pad. Okay. So this is the support. See this, and they have also a specification of degrees. Okay, so this is support and 120 degrees from the center of this. So this is the center line of the pipe. From the center they have a 30 degrees. Okay, and this pad will have 120 degrees. So this is the specification. You must follow these degrees or less rejected by inspector if you are not following that specification of degrees. Okay, so we have also weld symbols. So this is these symbols, if you see this circle, so this is weld all around. Okay, and arrow side 1/4 field weld if installed in the field. Okay, so they have also a note, field weld if installed in the field. Okay, so cross section, and we have elevation. So this is the elevation. We have, so this is 12 inch for the pipe within unit battery limits and 18 for all others. So the dimension of this pad. So this is also comment on note, 12 inch for pipes within unit battery limits and 18 for all others. So they have also minimum thickness. Minimum thickness pipe wall, maximum 3/4 thickness pipe. Minimum thickness pipe wall, maximum 3/4 thickness pipe. So they have a maximum 3/4 thickness of pad. Okay. And of course, this is a very important. So the whole of this pad. So they have also a specification what size of bent or hold to be used on this pad. So they have a 1/4 diameter bent hole in pad. Okay, what is the purpose of this pad? This is what is the purpose, or this is my question to you, all my subscriber and all to be watched on this video. Just leave a comment, and what is the purpose of this bent hole or 1/4 diameter bent hole in pad? What is the purpose of that bent hole? Okay, that is my question to all of you guys. And a specification, this is a steel support and elevation. Okay, so they have also a size with that using this pad. So on this cross section, so this is a cross section, this is the front view, this is the front view cross section, and we have, this is the side view. Okay, so this is the pad from the pipe. Okay, and specification from the support details and from the isometric drawing, you can see these symbols. You cannot see these symbols of pad. Okay, they have only written there the types of this support, but you cannot see this symbol of this pad. Sometimes they are the symbols there is a 5 shoe. Okay, but you cannot see these symbols of a pad. You can see there the pipe shoe, the trunnion, the guide. Okay, they have a lot of support in the piping. So this is the example of the support details. Okay guys, and that's all for now guys, and thanks for watching. Bye bye, have a nice day, see you. Hi guys, welcome back to Piping, Welding and TT channel. From this isometric drawing, so we will count it, how many fittings, how many bulb, okay, how many spool. Okay, so this is the job of the pipe fitter. You must check all the fittings, of course, in the BOM. And another call of BOM is material description. Okay, but the meaning of BOM is a bill of materials. Okay, anyway, from this isometric, first we will count it, how many fittings on this isometric. So first is 90 degrees. Okay, first is elbow. Okay, so how many elbow on this isometric? I think they have only one elbow. So this is one elbow. So this is it. Number 4. Okay, check in material description. Number 4. So this is our number 4. 90 degrees elbow. Okay, 90 degrees elbow. LR, long radius. How many quantity? So this is the quantity, only 1. Okay, 90 degrees elbow, 1 90 degrees elbow. Okay, we will back to isometric drawing. So only 1 elbow on this isometric drawing. Next is how many bulb. Okay, so we'll count it. So 1, 2. Okay, so this is also bulb. 3, 4, and 5, 6. So we have a 6 elbow. Okay, so to determine what is elbow type on this number 15, so check this in the BOM. Okay, number 15, because this is a globe bulb in the bill of materials. Okay, number 14, so this is a gate bulb. Okay, and at this one, number 16, you can check here in the BOM number 16, gate bulb. Okay, so this is 17. Okay, so this is we will check here. So this is an instrument, or this one is a motor operated bulb. Okay, so this is a small gate bulb, also gate bulb. Okay, so we will count it also how many spool. So this is one spool, this is spool 1 2 3, so they have 3 spool on this isometric drawing. Okay, so we have also 1 T, so this is T, and they have another, okay, only 1 T. OLED, we'll check is also the socket. So this is one, number 4, this is number 3, is socket 4 by 3/4 NPS, nominal pipe size. So this is a socket 1 2, they have 2 socket. That is how to check all the materials in this isometric drawing, which is the help of this beyond. This is the important from this isometric drawing. Need to be checked all the fittings, all the bulbs, all the pipes of spool. Okay, so this is it. So that's all for now, guys, and thanks for watching. Have a nice day. See you next time, guys. Bye bye. Hi guys, welcome back to Piping, Welding and DT channel. So this is example of support details. Okay, on these support details, they have a dimension, symbols, and size of support, and name of this support. So this is the type of support. So this support is, so anybody so this support is pipe, shoes, and guides and anchors. Okay, so from this detail 1, so this is a front view of pipe, and of course this is the side view of the I-beam. And we have also, so this is, see this triangle, so this is guide. See, so we can read here, so pipe guide, see table below. So this is the example of guide. Okay, but they have different of guide based on size of pipe, and based on what pipe to be serviced on that. Like for example, gas, vapor, liquid or gas. So they have different type of guide. So on this guide, they have also a symbols. So this is a symbols of welding. So if you see this arrow, so this is the arrow, and we have a plug here. So this is a plug. Okay, plug, and they have a size of weldment. So these triangles, it means this is a fillet weld, and size of fillet is 1/4. Okay, and they have also a tail. So tail, it means they can put here the specification of what type of process to be used on this support, on this guide. Like for example, on this tail is small shield metal arc welding. Okay, so this symbols is arrow side. If you put this triangle on this side, it means this is other side. Okay, arrow side and other side. Okay, so this is, now we have a number 1. So 1 is example of guide support. So on this side, okay, so there we have finish here. Okay, here pipe guide or concrete or steel support. So this is the pipe size 342 36 inches. Okay, nominal pipe size. So this is NPS, nominal pipe size 342 36 inches. Okay, and this is the side view of this front view of pipe. So this is the side view, and this is the guide, a pipe, and also the I-beam, concrete support and steel support. Okay, and this is a different also guide, pipe guide, see table below. Okay, and this is the specification of guide. They have a specification of clearance. This is 116 clear, clearance, and the length of this guide is 4 inches. And they have also weld symbols, fill weld, fillet weld, arrow side, and the diameter of bar. So this is diameter of bar 3/4. So all details is here in the support details. Okay, in isometric drawing you cannot see this support details, so they have a different drawing of this support, and you can see only in the isometric drawing is symbols. Okay, only symbols, not this support details you cannot see in the isometric drawing. They have isometric drawing, but only few isometric drawing you can see in this support detail on the top on the isometric drawing, but they are small support details in the other isometric, but they have no support details on isometric drawing. Okay, anyway, so this is a pipe guide. Okay, this is also a pipe guide. So all here on this support details is only a pipe guide. Okay, we don't have here a pipe shoe and anchor. Okay, so only this is, all of this is guide, pipe guide. So this is pipe guide for concrete sleeper, pipe size 6 inches through 36. See this one, they have, so BOP. So this is what I mean, you must also learn what is the abbreviation. So this BOP, bottom of pipe, and EL is elevation. Okay, diameter of bar 3/4. Okay, so that's all for now, guys, and thanks for watching. Have a nice day. Bye bye, see you next time. Hi guys, welcome back to Piping, Welding, and DT channel. Specification and drawing. So this is a specification of support. So this is the support details, and of course I have a specification based on codes and standard. So this is a pipe shoes. Okay, so in a Pipefitter they have a lot of support in the piping. They have a lot of support to be installed in the pipes. So this is a support details, an example of a pipe shoes. Okay, so this is a pipe shoes, and this pipe shoes is a welded type. It means this pipe is welded on this pipe. Okay, so this is the pipe shoe. So this is the pipe shoe. This is the I-beam, also front view, side view. Okay, and this is the guide. These two sides is, see this one, pipe guide, and welding symbols, fillet weld, 1/4 size. This is a 1/4 of weldment and type of to be used in this guide. Like for example, small, TIG, but always use here is small. Okay, so they have a clearance of this pipe guide. If you are installing this pipe guide, check this what clearance to be used on this pipe shoe. This is a very important to be checked, the clearance of this pipe guide. Why? If they have no, so because this is the specification by codes in the standard, right? And they're using this 1/16 inch. Okay, I think this is 3 millimeter. If you divide this one, divide 16, and this is the clearance both sides. So you have both sides is 1/16, so that the pipe they can. So if this is the pipe, they can move like this. If they have no gas, they have no what they call this is gap, the stress of the pipe is coming there. Okay, the stress. So if they have a clearance, just moving only like left and right, moving right. Okay, and this is the side view. Okay, steel support, concrete support, and fillet weldment symbols. So this is both side symbols. Okay, they have a both side symbols, and field weld type also. And this pipe guide, they have also and they have a dimension of this guide. All pipe size 2x2 by 3/8 by 4. Okay, so bottom of pipe and elevation. So elevation, diameter bar. So this is pipe guide for concrete sleeper, all pipe size. So if you see this, if you check the support detail, you must check one by one. And the welding symbols, and the sizing, and the specification. Okay, like for example on this gap 1/16. So that one is very important, because if a QC check this guide, you don't have a gap, QC rejected this guide if no have gap. Remove that one, and put a gap based on the specification of the support details. Okay, and also they can put in the punch list. If this is line checking, if a QC line checking this line, if see there's no gap, they can comment it modified and put a gap based on the specification. Okay, so that's all for now, guys, and thanks for watching. Remember, this is a 5 shoe, and have a nice day. Bye bye and God bless all. Hi guys, welcome back to Piping, Welding and DT channel. So again, this is specification, support, details. So in my other videos, they have guide and pipe shoe. Okay, so this is a pad. Okay, so this is the support. See this, and they have also a specification of degrees. Okay, so this is support and 120 degrees from the center of this. So this is the center line of the pipe. From the center they have a 30 degrees. Okay, and this pad we have 120 degrees. So this is the specification. You must follow these degrees or less rejected by inspector if you are not following that specification of degrees. Okay, so we have also weld symbols. So this is these symbols, if you see this circle, so this is weld all around. Okay, and arrow side 1/4 field weld if installed in the field. Okay, so they have also a note, field weld if installed in the field. Okay, so cross section, and we have elevation. So this is the elevation. We have, so this is 12 inch for the pipe within unit battery limits and 18 for all others. So the dimension of this pad. So this is also comment on note, 12 inch for pipes within unit battery limits and 18 for all others. So they have also minimum thickness. Minimum thickness pipe hole, maximum 3/4 thickness pipe. Minimum thickness pipe wall, maximum 3/4 thickness pipe. So they have a maximum 3/4 thickness of pad. Okay, and of course this is a very important. So the whole of this pad. So they have also a specification what size of bend or hold to be used on this pad. So they have a 1/4 diameter bent hole in pad. Okay, what is the purpose of this pad? This is what is the purpose, or this is my question to you, all my subscriber and all to be watched on this video. Just leave a comment, and what is the purpose of this bent hole or 1/4 diameter bent hole in pad? What is the purpose of that bent hole? Okay, that is my question to all of you guys. And a specification, this is a steel support and elevation. Okay, So they have also a size with that using this pad. So on this cross section, so this is a cross section, this is the front view, this is the front view cross section, and we have, this is the side view. Okay, so this is the pad from the pipe. Okay, and specification from the support details, and from the isometric drawing you can see these symbols. You cannot see these symbols of pad. Okay, they have only written there the types of this support, but you cannot see this symbol of this pad. Sometimes they are the symbols there is a 5 shoe. Okay, but you cannot see these symbols of a pad. You can see there the pipe shoe, the trunnion, the guide. Okay, they have a lot of support in the piping. So this is the example of the support details. Okay guys, and that's all for now guys, and thanks for watching. Bye bye, have a nice day, see you. Hi guys, welcome back to Piping, Welding and DT channel. So this is for you, Pipefitter, and of course all related in the piping. This is a simple information, and this is a very important in piping works. Okay, so this is piping design data, and we have nominal pipe size 5 inch. Okay, so in millimeter this is 125 millimeter. So in piping parts dimension and weight, we will start from pipe. So this is pipe in ANSI B36.10 and 36.910, butt weld fittings ANSI B16.9. so this fittings is for butt weld, so meaning of BW is butt weld fittings 36.19 and 16.9. so this is for 36.10. okay, so we will start from 5. So this is for nominal 5 size inch. So this is the outside diameter for the dimension. Okay, they have a 141.3 and the radius is 70.65. okay, next for the elbow, so this is 90 degrees elbow. They have a LR and SR. So LR is long radius and SR is short radius. In LR we have a 190.5, SR 127. okay, so this is a 45 degrees 79.4. so this is for 5 inch. okay, 5 inch 125 millimeter in millimeter. okay, so next is T. So this is a takeoff of T in 5 inch 123.8. so this is the table of 40. We have a size of 432 and 117.5, 111.1, 10.8, and this is for the reducer. So this is the number for the dimension of the reducer. Cap dimension, so this is a minimum 5 for 5 inch. So we have a 50. okay, so this is a 50. So it means if we have a fittings to fittings, so this is a concentric reducer and we have 90 degrees elbow, we will connect for the minimum. If we will install the 5, we will put a minimum of dimension 50, no other than lower. Okay, lower 50, this is not acceptable. So minimum 50 up. So this is stub end, this is in dimension, and we have a welded. Okay, in the welded they have a thickness and weight. Okay, so this is it. So this is thickness. So we have standard XS, schedule 160, and WXS 50, 57.2, 57.2, 93.7. This is the weight of this welded. 4.6, 4.7, 6.5. Okay, now this is, we have so this is a table, fittings of 8 kilogram. So we have a pipe here, elbow 90, elbow 45, T reducer cup, and this is the weight based on the thickness. Okay, let for example on the 5, schedule 9, this is schedule 5S, 10S. Okay, standard 40, 120, double XS. So this is a thickness. Please take note that one, this is a kilogram per meter. Okay, so this is it. So in 5S, we have a 2.77 millimeter thickness, and the kilogram is 9.46. Okay, per meter. Okay, kilogram per meter. Okay, and of course also 90 degrees elbow, and we have a cap and a stub end. So please take note all this. So this is a very important information. Okay, so this is fittings to fittings, connecting. So we have a reducer T, elbow reducer. Okay, and they have a dimension there, and they have dimension also here. So also this one, so connecting to fittings, elbow 45, and reducer. This is some dimension. So this is a specification for all fittings to be connected. Okay, next is flange. So this is a flange and flange fitting. So that one is the dimension. Okay, SO, meaning of SO, slip on flange plus pipe, and all these A, C, D, and they have a dimension here. Okay, so weld neck flange, slip on flange, pipe plus 90 degrees elbow, weld neck flange plus 90 degrees elbow, slip on flange plus pipe plus T, weld neck flange plus T, and weld neck plus maximum size of pipe in 1 inch. So this is the table of all these flange and fittings dimension. So this is a flange ANSI B16.5 bulb and ANSI B16.10. So this is it, the dimension. Okay, let for example we have SO plus pipe. So A dimension of this, slip on flange, slip on A dimension A. So this is the dimension based on classification. We have a 25, classification 300, 600, 300. Okay, based on, like for example we have a dimension A class 600, so this is the dimension 330 for this. Okay, well, please take note that one all, and this is a very useful in the piping works. Okay, this is it. So we have also and bolt, weight, gate, globe, and check bulb. So this is all bulb, check bulb, globe bulb, gate bulb, and we have also weight, bolt. They have the diameter of bolt, stud, machine bolt. Okay, based on classification of course. So, and of course they have a dimension of bulb here. So this is the dimension of bulb, and check from here all from the table. Check here what is the dimension and based on the classification. Okay, so that's all for now, guys, and thanks for watching, and have a nice day. Don't forget to subscribe and just leave in a comment. Bye bye, see you next time. Hi guys, welcome back to Piping, Welding and DT channel. So this is abbreviation, piping abbreviation. Okay, we will start it in AG. The meaning of AG is above ground. Okay, ARRGT, this is arrangement. ATM, atmosphere. BF, blind plants. BL, battery limit. BOP, bottom of pipe. BUT, this is butterfly bulb. Okay, and BW, butt welding. So this very important abbreviation. Okay, so please take note this one all, because during interview, sometimes this is a #1 topic for the interviewer, this piping abbreviation. Okay, so please take note all this. Check bulb, center line, concentric reducer. Okay, and connection, continuation. The example of question is, what is CR, what is CS, like that. Carbon steel. CSC, this is car sealed close. Okay, bulb. CSO, car sealed open. Okay, so we have also drain, diameter, discharge. Okay, DN, the meaning of DN, this is always see in the isometric drawing. So this is DN, nominal diameter. So E is, okay, and they have also eccentric reducer. Okay, elevation, electrical. So this is piping abbreviation. Okay, so next is, so please take note all. So make up length, millimeter, midge line, minimum, this is minimum. So LR, so long radius. LO, lap open. LF, lap flange. Okay, this is all abbreviation in the piping. Also you will see also this one in the isometric. LC, lock, close. So this is the meaning of found. Okay, the abbreviation, I mean. Okay, instrument installation, hose reel, hose connection, globe bulb, gate bulb. This is FB, full bore, flat face, flange, fixed joint. Okay, take note all that one, guys. So next, this is all. North, normally closed, normally open, number, nozzle, national, pipe thread, nut to scale, nominal bore, NB. Okay, OD, outside diameter, power socket, the PNID. Oh, this is important, piping instrument diagram. Okay, PNID. Platform, pipe support, PS, Okay, radius R, RF raise face, RO restriction, orifice, RTJ ring type joint. Okay, this is one south. Sample connection schedule 5 screwed, sleeve on flange, short radius, SS stainless steel, ST steam trap, STD standard, structural suction, socket frame, and this one is symmetrical. Okay, so this is number one important in the piping. So this one, please take note all this, also this one, welded. Okay, guys, please take note all this one, guys. Utility connection underground. So this is also number one question by interviewant, TYP. This is a typical. Okay. So that's all for now, guys, and thanks for watching. And don't forget to subscribe and just leave a comment if you have a comment for this abbreviation, piping abbreviation. And see you in my next video, guys. Bye bye and have a nice day. Thank you. Hi guys, welcome back to Piping, Welding and DT channel. So this video is regarding 45 degrees isometric offset. Okay, I will draw an vertical and horizontal shadow, and we will convert it to 45 degrees a flange view. Okay, so first is this is our north. So this is very important. You must know where is the orientation northing. Okay, so first drawing, and this is our line. Okay, and I will put here and shadow. So this is a vertical shadow. Okay, and next is this is our line. Okay, and this is also a vertical shadow. Okay, and we will convert this vertical shadow in the flange view. Okay, so first this one. Okay, we will convert this. So we have number 1 and 2. So number 2, we will convert this one in the flange view. So in the flange view, this is our northing in the flange view. Okay, so this is our northing, and this is a flange view, and our flange view for this line is like this. Okay, we have a dotted line here, and we have half C. Okay, and another half C here, and we have another dotted line here. So this is a plan view for this vertical shadow. Okay, the meaning of this vertical shadow is a 45 degrees. Okay, so next is number 1. So this number 1, we will convert this in the plan view. So in the plan view, line, and then half C again 2, because this line is going up. Okay, going up. And we have also an half C there, and we have a dotted line. It means this is going down. Okay, so this is a conversion from the isometric drawing and the plan view. So this is all a type of 45 degrees offsets. Okay, so next is another example of this vertical shadow. So again, here's our northing and box. Okay, and this is our line, joint, and this is our shadow. So this is also a vertical shadow. Okay, and we will convert this one for the plan view. So this line and another dotted line there, dotted, half C, and another half C and dotted line. So this is a conversion of plan view. Okay, so another one is this one. For the horizontal shadow, so this is the horizontal shadow line, so this is the example of horizontal shadow. And for the plan view, this is the plan view. Okay, so this is 45 degrees offset and 45 degrees plan view. So thanks for watching, guys, and have a nice day. Bye bye. Hi guys, welcome back to Piping, Welding, and DT channel. So this is isometric drawing, and I will show you how to determine this all shadowing here in isometric drawing. So if we can see, we have a lot of shadowing on this isometric drawing. Okay, so how you determine if this is a vertical or horizontal shadow? Okay, in practical, if you are confusing for this all shadow, you must create box. So this is a technique to determine whether you are confusing to determine this all shadowing. And of course, elevation. Okay, check all the elevation. Okay, so on this ISO, so we have, so this is S4. Okay, symbol of supports. And so this is a shadow. Okay. So check the elevation. Check the elevation. Okay. This is the elevation 52963. And check also another elevation from here. So this is 50963. So this is an horizontal. Okay, so they have millimeter going down, because we have a 50963 and this one is 52, so they have a slope. Okay, check another one shadow. So 50963, and we will check here the elevation of other. Okay, do you see? This is 50963 and 50963. It means this is an horizontal shadow. Okay, so this is horizontal, and other one horizontal also, but they have an slope 52 and 50. Okay, so this is how to determine the slope. Okay, and we will check it another one. Another one shadow. So on this shadow, the dimension from here and from here is the same, 1151151. So it means this is a 45. Okay, we will check here the elevation. This is elevation 5117, and another one is 5110. Okay, here is 5117, and the another one is 511. It means this is also have an slope. Okay, going here, the slope. So this is the example of shadowing from the isometric, and determine whether this is vertical or horizontal. So they have a symbol also there, support. So this is support. Okay, and we will check also the other one shadowing. Okay, so this is a shadow also. So this is a lot of a shadow for this isometric, and we will check here the 5117 and 5117. So this is horizontal and they have no slope. Okay, so this is all horizontal shadow. Okay, if you see also this one symbol, this is a flow direction. Okay, this small triangle there. So that's all for now, guys, and thanks for watching. Have a nice day. See you next time, guys. Bye bye.